So today's going to be lesson 4.5. We're going to be looking at solving inequalities that look like the equations that we solved in 4.4. So you're going to have variables on both sides. You have ax plus b and cx plus d on the other side, but instead of an equal sign, making it an equation, it's going to be a less than or a greater than sign. So for the most part, it's very similar. We just have to remember that when we multiply or divide by a negative, that we have to flip our inequality. The less than becomes a greater than or vice versa. And so we want to talk about strategies of staying away from our negatives so we don't even have to worry about flipping it. So the very first step is always going to be the most important one. And we talked about if you always get rid of the smaller of the two variables, meaning the coefficient, the number in front, if you always eliminate the smaller of the two, you create positive numbers. And if we stay in the positives, then we never have to actually flip our inequality. If we're going to make a negative, we're going to end up dividing by a negative, and then that's going to flip our inequality. So the best tip I can give you is to just continue always getting rid of that smallest of the two. So in this case, the 3, you're going to minus it away. It's going to create a positive, and then you're never going to have to divide by a negative, and you're never going to have to flip your greater than sign. And then it's pretty much just like working with an equation. So right here we have 3a. I'm going to minus 3a from both sides so that it's eliminated. So I have 4a plus 4 greater than 28. Make sure that you're writing the greater than sign. A lot of students will just automatically write equals because that's what they're used to, but keep that greater than sign going all the way down. And now at this point, we got no worries here. We're minusing 4 from both sides. So 4a is greater than 24. Divide. We're dividing by a positive, so we're going to bring that straight down. So a is greater than 6. Perfect. Nothing weird there because we didn't create any negatives. So now let's do our checks. So check number 1, again, we go back to an equal sign and we see if 6 is the correct number. So we're going to do 7 times 6 plus 4. Does it equal 3 times 6 plus 28? So we're going to get 42 plus 4, so 46. And on this side, we're going to get 18 plus 28, which is 46. And then do remember that we need to come up with another check for an inequality. And now we're not checking the number itself. We're checking to see is our less than or greater than sign correct. So since a is supposed to be any number greater than 6, I'm going to pick a number bigger than 6. So not 0. Everybody always wants to pick 0. That's a good number to choose if it fits your solution set, but a needs to be greater than 6 in this case. So I'm going to pick 10 and work with that. Slide over here so you can see it. So we're going to multiply, and we're going to get 74 on the left. We're going to get 30 plus 28. Oops, and I already messed up. This should be your greater than sign, not an equal sign, because we're testing to see if our greater than or our less than sign is correct. So we're going to get 58 over here, definitely not equals. That's how I noticed. So we got to say, is this statement true? Is 74 greater than 58? Yes, it is. Now, if it says 74 is less than 58, we know we've got an issue with the direction that this is facing. All right, so there's your basic one. Let's slide down to example number 2. So taking a look at this one, very similar. Okay, so we've got, well, if we go back to example number 1 for a real quick sec, we forgot to graph. So if we wanted to graph this, here's 0, so positive 6 is up here. It says greater than, it's an open circle, so it doesn't include the 6. We know how to do this. Okay, so there's our graph. So let's not forget to do that on number 2. So as we slide down to number 2, I've got an x on both sides of my inequality, and so I need to eliminate the smaller of the two to stay away from my negative numbers. So what I would want to do here is I would want to add 11x. Okay, so that leaves me 7. I haven't multiplied or divided by a negative, so I'm not flipping. It's going to give me 15x plus 12. Pretty straightforward from here. minus 12. To get me negative 5 and 15x. And now I need to divide by the 15. So our 15s here are going to cancel. And this can simplify. You can divide in your calculator. You're going to get 0.3 repeated. So that's 1/3. So it's negative 1/3. I divided by a positive number, so I'm not flipping this. All right, and I get this. Now for this one, I know it says graph and check. But instead of doing that, what I want to do is go back to the original and show you what happens if you decide to get rid of the bigger of the two coefficients. So what if we decided to get rid of the 4 for whatever reason, and we want to minus 4x? Okay, it's going to go away here. We're going to get 7 minus 15x and 12. You can see the similarities here. We're going to minus 7 now because we're trying to get rid of that x. And so we bring down, we have a negative 15x. We haven't multiplied or divided by any negatives yet, so we're not flipping anything. And we're going to get 5. But now right here, we're dividing by negative 15, which we created because we didn't choose to get rid of the smaller of the two, which is the negative 11. All right, we get x. We still get negative 1/3. But if you take a look, because we divided by a negative, we need to flip this inequality. And now it's going to face this way. And we still got it right. So it's open towards the x. It's open towards the x, negative 1/3, which is the correct answer. Okay, so you can still get it right, but we have to remember to flip. And how many of you forget to flip so often? So if we just stay in the positives by getting rid of the smaller of the two coefficients, we don't even have to worry about flipping. So that's going to be our best practice with those. All right, so if we move to page 2, now we're going to look at these kind of in a word problem. So we're going to write this out and then see if we can't answer the question. So it says 5 times a number. We don't know the number, so let's call it x. So 5x is less than 3 times the same number. So I got to use the same letter because it's the same number in both spots. Find the number. So all we need to do is solve this. Well, this looks a little weird because you're like, well, I'm going to eliminate one of these. There's going to be nothing left, which is okay. When that happens, you have to replace it with 0. So of these two, I'm going to get rid of the smaller, so the 3x. So it goes away here. I can't just leave it blank. I need to replace it with 0. I have not multiplied or divided by a negative, so keep the inequality facing the same way. We're going to get 2x. Technically, we're going to divide by 2, but we should already see that x is going to be less than 0. So that means it can be any number smaller than 0, meaning negatives. Why does this make sense? Let's take a look. If you plug in any positive number here, or even 0, if you plug in 0, 5 times 0 is 0, 3 times 0 is 0, it's going to say 0 is less than 0. That's not true. And if you plug in positive numbers, the same number, times 5 and times 3, and then this side's supposed to be less than this side, that's not going to be true. But if you plug in any negative number, say negative 2, you're going to get negative 10 and negative 6, and negative 10 is less than negative 6. So any number less than 0 makes this true, meaning any negative number. All right, so basically, when you clear out an entire side, you do need to leave a 0 over there. Don't just leave it blank. All right, so example number 4. Now we got a word problem. We're going to write it out, and we're going to use these skills to solve it. So Jamie's got $40 in the bank account. She's going to start depositing a certain amount every week. So we know what these look like. That's 40 plus $15 a week. The other guy, Mark, he's got $120, and he deposits $5 a week. So when we worked with equations, we wanted to know when were these equal to each other. We were solving for when do they have the same amount of money in their account. Well, what if that's not what we're solving for? So write and solve an inequality for the following. When will Jamie, and that's Jamie right here, and this is Mark. When will Jamie have more money? When will she have more in her account than Mark? So how do I write that as an inequality? So Jamie, when does she have more? So when is her account greater than his? Because when they start out, she's got $40, he's got $120, but she's putting more in every single week. So at a certain point, and from that point forward, she's going to have more money in her account. So let's go ahead and now solve this inequality. Smaller of the two, keep yourself in the positives. That would be the 5. So we're going to minus the 5 away. Looks like this. Now I'm going to minus 40. Trying to get W by itself. I have not multiplied or divided by a negative, so I'm not flipping anything. Divide by positive 10. Okay, and that's on purpose. We specifically got rid of the smaller of the two coefficients, so we would end up dividing by a positive number. So these cancel. I don't need to flip anything, and I get 8. So for any number greater than 8, so can we answer the question, when will Jamie have more money in her account? So you got to be careful how you say it. If you say after 8 weeks, that's not true, because W has to be greater than 8 weeks. So if you say after 8 weeks, it sounds like you're saying starting at 8 weeks, she's going to have more. At 8, they're going to actually probably be equal. If we ran the equals here, we would have had W equals 8. So they're going to have the same amount of money after 8 weeks. So when will she have more money? So she will have more money in 9 weeks or more. Now there's other ways to word that, but again, we can't include week 8. In week 8, they're going to have the same amount. We want to make sure we're being really clear that she's going to have more in 9 weeks or more.